welcome back. So what we're looking at today is 3.5, throwing an interception. So let's go ahead and get started. All right, for this first part, while working with areas, it's sometimes essential to convert between units of measure. For example, changing from square yards to square feet and so forth. Convert the areas below to the desired measure. Hint, area is two-dimensional. For example, 1 yard squared equals 9 feet squared. Along each side of a square yard equals 9 square feet. So if you think about regular conversions, 3 feet is the same as 1 yard. So when we're squaring it, when we're dealing with area, think about it as 3 times 3, which gets us that 9. So it's taking and squaring each of our values in this case. So for the first one, number 1, we have 7 yards squared equals blank feet squared. So we're converting between yards and feet. So being as we're going from yards to feet, we need to multiply our yards by 9, because in 1 yard there's 3 feet, and we're dealing with squared, so it's 9 square feet. So 7 times 9 is 63 feet squared. Now, for number 4, we're converting from 100 meters squared to centimeters squared. So meter to centimeter is 100, so we double that, so it's 10,000. So it means we're going to multiply by 10,000. So we're going to end up with 1 million centimeters squared. Since we're taking 100 times with 10,000, which is going to give us 1 million. So be careful when you're taking and doing these. Your inches to feet, just as a reminder, inches squared to feet squared is going to be times, feet squared to inches squared will be times 144, because for every foot there's 12 inches. We square that, we get 144. In a mile, there are 5,280 feet in a mile. So use these different conversions to help you as you're answering 2, 3, 5, and 6. Okay? Alrighty. So the next thing we're looking at here, number 7. So for some reason, this document doesn't want to let me write on it. So I have a rough sketch of what these 3 equations look like graphed out. But I'll talk you through how we're going to take and do them. So for graphing each of the quadratic functions, f of x equals x squared. So that's the parent function. So for that, you'd start at the origin. Then when we plug in 1 squared is 1, 2 squared is 4, 3 squared is 9, and then we do the symmetry for that. In the next one, we have g of x equals x squared minus 9. So the parent function, but translated down 9. So we'd start down here at negative 9, and then plug in 1. 1 squared is 1, minus 9 is negative 8, so it'll be at negative 8 for both 1 and negative 1. Then we plug in 2, 2 squared is 4, 4 minus 9 is negative 5, so it'll be at negative 5 for 2 and negative 2. And for 3, 3 squared is 9, 9 minus 9 is 0, so 3 and negative 3, we will be on the x-axis. The last one, h of x equals x plus 2 quantity squared minus 9. So this one, we're translating it down 9, but then we also have to go over to the left 2, because remember, this plus 2, it's telling us the opposite direction. So while we think, okay, we should go to the right because it's positive, we actually want to go the opposite way. So we're going to go over to the left. And then same idea. So in the end, what this should look like approximately, like I said, mine's not perfect because I didn't have exact grid lines here. It's a rough sketch. But this function right here, this is our f of x. So there's our parent function. Then this one here, we had our vertex translated down to the -9. So this one is the g of x, and this one is the h of x. So it's moved over to the left 2, down at -9, and there we have our parabola. So like I said, very rough sketch. I apologize for not being able to write on the actual graph there so you can see it a little better, but this is essentially what you're taking and looking at for those graphs. So for B, it asks, how do the functions compare to each other? So how are these similar? Well, they're the same, it's just what happened. We translated them. So same, just translated. Flip this back. So they're the same, they are just translated. For C, how do g of x and h of x compare to f of x? So our g of x, remember, is the one where we went down 9. So g of x is down 9. And our h of x is down 9 over to the left 2. So there's the relationship there for how they compare. For D, look back at the functions above and identify the x-intercepts of g of x. What are they? So if we look back, here's our g of x. Notice it's crossing here and here, which this is at 1, 2, 3, and 1, 2, or -1, -2, -3. So it's at +3 and -3 are our x-intercepts. So 3, 0, -3, 0. And then for E, what are the coordinates of the points corresponding to the x-intercepts in g of x in each of the other functions? How do these coordinates compare to the others? So when we're looking at our h of x, let me flip this back around. We have an x-intercept here at 1, and then over here at 1, 2, 3, 4, -5. So we've got 1 and -5 for x-intercepts. How does that compare to 3 and -3? Well, it's 2 less in each case, right? So 1, 0, -5, 0. Values are 2 less, which makes sense since our h of x got shifted to the left 2, so we're going in a negative direction, so it makes sense that each of our x values are 2 less than the previous x-intercepts that we had on our g of x function. So there's some looks at transformations with our parabolas and their symmetry and just all those relationships there. So you guys will be looking at doing the same thing on 8. So you have 3 functions, you'll graph those out and then answer the questions about those. So looking at x-intercepts, looking at how do they compare, what's the translation on them, all of that, okay? All right, the next section. We are looking at function notation and evaluating functions. So use the given functions to find the missing values. And if you want, you could check your work using a graph. You do not have to, but you could. All right, so for number 10, we have f of x equals x squared plus 4x minus 12. What we want to do first is plug in 0 for x. So we have f of 0 equals. So that means we're taking our 0 and we're plugging it in for x in both places. So be careful with these. You have 2 places they have to get plugged into. So we're going to have 0 squared plus 4 times 0 minus 12. Well, 0 squared is just 0. 4 times 0 is 0 minus 12. So this equals 0 plus 0 minus 12, which is just negative 12. So f of 0 equals negative 12. So when our x value is 0, our y value is negative 12. Now, f of 2. When x is 2, we're going to find out what our y value is. So we substitute in the 2 in for both of the x's. So we're going to have 2 squared plus 4 times 2 minus 12. 2 squared is 4. 4 times 2 is 8. And then minus 12. 4 plus 8 is 12. Minus 12 equals 0. So when x is 2, our y value is 0, which means this is an x-intercept for this function here. Now, for C and D, it's a little different. This time we know what the function equals, so we know what the f of x is, and we need to find what the x values are. So we set it equal. So you're going to have 0 equals x squared plus 4x minus 12. Now, we can't just take and subtract or add the 12 over and then solve. You want to use factoring on this. So we have our ability to take the 12, find the two things that multiply to give us negative 12, and add to give us 4, which is going to be a positive 6 and a negative 2. So we have 0 equals x plus 6 and x minus 2, because 6 times 2, or 6 times negative 2 gives us negative 12, and positive 6 minus 2 will give us a positive 4. So now each of these needs to be set equal to 0. So we have x plus 6 equals 0 and x minus 2 equals 0. We solve for x in both cases. So subtract 6, x equals negative 6, and add 2, x equals positive 2. So when we're dealing with quadratics, remember, we can have more than one x-intercept, and that's what this is looking at here. So we have our negative 6 and positive 2. So those are our x-intercepts, both of them. Here we found one of them by seeing that the y value is 0. Here we found both of them by factoring. All right, the last one we have f of x equals 20. So for this, same idea. We're going to set 20 equal to x squared plus 4x minus 12. So now, from that, we're going to solve. We need to make this 0 in order to solve. So we're going to subtract the 20 from both sides. So now we have 0 equals x squared plus 4x. Negative 12 minus 20 is going to give us a negative 32. So now we need to find the two things that multiply to give us negative 32 and add to give us positive 4. Well, with 32, we have 1 and 32, 2 and 16, and, whoops, not 3, sorry, 4 and 8. Now, we need to make one of these values negative and the other positive. Well, looking at these, 32 and 1, that's never going to give us 4. 16 and 2, that's never going to give us 4. But a positive 8 and a negative 4, that is going to give us 4. So our factors are 0, are x minus 4, and x plus 8. Now, just like before, we set these equal to 0. So 0 equals x minus 4. Add the 4. So 4 equals x. So 4 is one of them. And 0 equals x plus 8. Subtract the 8. Negative 8 equals x. So 4 and negative 8 are solutions for this. So when we're looking at these, you're going to have two values for your x values. So be very careful because we're looking at x-intercepts, okay? All right, we're going to do one more as an example just to help prepare you. So for this next one, we have to solve a little differently when we do this.